Hello students, a function f is such that fx equals to ln of 2x plus 1 for x greater than minus half. So 3a says write down the range of f. Now if I'm putting down the range of f, so since they have already restricted the domain that x has to be greater than minus half, so our fx can take all real values. Now that's the range of the function defined. If I'm going for the second part, a function g is such that gx is 5x minus 7 for all x belonging to real numbers. Find the exact equation of g of fx equals to 13. So if I'm going for 3b, so I should write it as g of fx. So that means the fx function is g of ln 2x plus 1. So that means in place of x in gx, we'll be writing ln 2x plus 1. So that becomes 5 of ln 2x plus 1, and that's bracket closed, and that's minus 7, and they have given that that's equals to 13. So if I'm solving this equation out, so I'll get ln of 2x plus 1 as equals to 20 divided by 5. So we got it as ln of 2x plus 1 as 4. So we got 2x plus 1 as e to the power 4, and the value of x that we got is e to the power 4 minus 1 by 2. So that's the value or the solution of this particular question. Now, moving on to the C part of the question 3C, they said, find the solution if f dash x equals to g inverse x. So, if y is equal to ln of ax plus b, and if I'm finding the derivative of this function, which is dy by dx, so it should be 1 by ax plus b into derivative of what is given in the bracket, so that's a. So here y equals to ln of 2x plus 1. So the derivative, if I'm finding dy by dx, has to be 1 by 2x plus 1 into 2. And that's equals to g inverse x. So to get g inverse x, we'll write y is equal to 5x minus 7. So we'll make x as a subject, which should be equal to y plus 7 by 5. So that is equals to f inverse y. So if I replace now y with x, so the value of my f inverse x should be x plus 7 by 5. So that's the value of f inverse x. Now they have said that f dash x, which is this value, which is dy by dx, is equals to f inverse x. So that means is equals to g inverse x rather. So this is a g function. So this is g inverse y. So if I equate the two values, so I get 2 by 2x plus 1 must be equal to g inverse x, which we got it as x plus 7 by 5. So if I cross multiply and open the brackets, so we got it as 2x squared plus 14x plus x plus 7, and that should be equal to 10. So we got it as 2x squared plus 15x, and that's minus 3 equals to 0. So we got this quadratic equation. Now we'll be using the quadratic formula to get the two values of x. Before that, if I explain the marking scheme, so writing the range correctly, you get 1 mark for this. Now, if I move on to the second part, so writing this equation correctly, which we got, you get 1 mark for this. And writing down the values correctly for x, you get 2 marks for this. Now, if I go to the marking scheme of the 3C part, so writing f dash x correctly, that gives you 2 marks here. Getting the expression for g inverse x, that gives you a mark here. Now, equating and getting a quadratic equation here gives you 1 mark. Now, we have to calculate the two correct roots, and that will give us the further 2 marks. So for that, if we are solving this equation, so we can write 2x squared plus 15x minus 3 equals to 0. So if I compare it with the standard quadratic equation, ax squared plus bx equals to c. So the two values of x that we get is by the formula minus b plus minus root under b square minus 4ac divided by 2a. So in this case, the value of a is 2, the value of B is 15 and the value of C is minus 3. So if I'm using this formula, so I'll get it as minus 15 plus minus 15 square, so that's 225 minus 4 into A and into C, which is minus 3. And that's divided over 2A, so that's 4. So the two values that we got for this is 0.195 and minus 7.69. So you get 1 mark for writing these two values correct. Now, this is a log expression, so x cannot be negative. So we'll only have the positive answer for x. So the correct answer should be 0.195. For writing this correct, you get another 1 mark. Thank you, students.